Now we are going to discuss some numerical problems on quantum mechanics. The ground state and the excited state normalized wave function of an atom are psi naught and psi 1 respectively, and the corresponding energy being E naught and E1. If the probability of finding the atom in the ground state is 90% and for the excited state is 10%, then find the average energy of the atom. Also determine the normalized wave function of the system. So it is a two-state system. E0 be the energy of the ground state and the corresponding wave function of this state is given by psi naught, whereas E1 is the first excited state and the wave function is given by psi 1. And it also given that 90% probability of finding the atom is in the ground state and 10% in the excited state. As we have to determine the normalized wave function of the system, we know the general state of the particle is the superposition of these two states. That is, we can write the general state of the system as psi is equal to C naught psi naught plus C1 psi 1. That is, psi naught being the wave function of the ground state and psi 1 being the wave function of the first excited state, and mod of C0 square and mod of C1 square gives us the probability of finding the particle in the ground state and the first excited state respectively. Given that psi 1 and psi 2 know, here the ground state wave function is psi naught and the first excited state wave function is psi 1 and they are normalized. So we can write by using the orthonormalization condition of wave function, it is integration minus infinity to plus infinity psi naught star x psi naught x dx, that is minus infinity to plus infinity mod of psi naught x square dx is equal to 1, and similarly minus infinity to plus infinity mod of psi 1 x square dx is equal to 1. But we also can write minus infinity to plus infinity integration psi naught star x psi 1 x dx equal to minus infinity to plus infinity integration psi 1 star x psi naught x dx equal to 0. So by using the orthonormalization condition, we have these 4 conditions which we have to use in the upcoming problem. The general state of the system using the superposition principle we have written as psi is C naught psi naught plus C1 psi 1, and we know for the normalization condition of this state is minus infinity to plus infinity integration mod of psi square dx is equal to 1. So if psi is C0 psi 0 plus C1 psi 1, then what will be the psi star, its complex conjugate? It will be C naught psi naught plus C1 psi 1 complex conjugate of the whole into dx is equal to 1. Now if I just multiply and separate it, we have mod of C0 square minus infinity to plus infinity integration mod of psi naught square x dx plus C0 C1 star minus infinity to plus infinity integration psi 1 star x psi naught x dx plus mod of C1 square integration minus infinity to plus infinity mod of psi 1 x square dx plus C1 C naught star minus infinity to plus infinity integration psi naught star psi 1 x dx is equal to 1. So just we have separated and multiplied the terms, and now we have to use the normalization condition. Now from the normalization condition, we have psi naught and psi 1 are the normalized wave function of the ground state and the first excited state, and we have the following 4 conditions which we have to use in our expression which we have just obtained. And if we put back here the value of the integrals, first and the third integrals is 1 and the other two are 0. So we have mod of C naught square plus mod of C1 square is equal to 1. And we know the probability of finding the particle in the state psi naught and psi 1 are 0.9 and 0.1 respectively, which is given according to the condition. Therefore we can write psi is 0.9 root over psi naught plus root over of 0.1 psi 1. So this is the normalized wave function of the state. And we know the average energy of the atom can be written as E average sum over of Pn En. Pn is the probability of that particular state and En is the corresponding energy eigenvalue of that state. We know that 0.9 is the probability of the occupying the ground state, and energy is E naught, and P1 is 0.1 and the corresponding energy is E1, so the average energy will be 0.9 E0 plus 0.1 E1. So this is the value of average energy of the system. This is a similar type of problem where a system has two energy states, epsilon naught and 3 epsilon naught, and psi 1 and psi 2 are the corresponding normalized wave function of these two states. At an instant, the system is in a superposed state, psi is equal to C1 psi 1 plus C2 psi 2, and it is given that C1 is 1 by root 2. Now find the value of C2 for which psi is normalized, and what is the probability that an energy measurement would yield a value 3 epsilon naught, and also find out the expectation value of energy. And we know the similar type of problem we have just solved. Here it is again a two-state system. E naught, that is the epsilon naught, and 3 epsilon naught are the energy of the ground state and the first excited state, and psi 1 psi 2 being the wave function. Now the general state of the particle is the superposition of these two states, and this can be easily written as the psi is C1 psi 1 plus C2 psi 2. So this is a superposed state. Now we have given the value of C1, we have to obtain the value of C2 for which psi is normalized. Given that psi 1 and psi 2 are normalized wave function, so we can have the following relations by using the orthonormalization condition of the wave function, that is minus infinity to plus infinity integration psi 1 star psi 1 dx is equal to 1. Similarly, that applies for the state psi 2 also, and minus infinity to plus infinity integration psi 2 star psi 1 or psi 1 star psi 2 dx is equal to 0. Now if we use the superposition principle, the general state of the system, it is a two-state system, can be written as psi is equal to C1 psi 1 plus C2 psi 2. And we know for the normalization condition of this state we have minus infinity to plus infinity mod of psi square dx. So if psi is C1 psi 1 plus C2 psi 2, then what will be the psi star? It will be C1 star psi 1 star plus C2 star psi 2 star. If we put back all these in this integration and just multiply it, we get the 4 possible integration, and by using the normalization condition, the first and third integral remains, other two vanishes, and using the previous condition we have mod of C1 square plus mod of C2 square is equal to 1. Here C1 is given is 1 by root 2. Therefore by using this we have C2 is 1 by root 2 again, and the normalized wave function psi can be written as putting the values of C1 and C2, it is 1 by root 2 psi 1 plus 1 by root 2 psi 2. Therefore, if I use the theory, the probability that an energy measurement would yield a value 3 epsilon naught, that is the particle in the second excited state, the state psi 2 can be easily written as P of the second excited state is mod of C2 square, we know, and 1 by root 2 square, that is half. So half is the probability that an energy measurement would yield a value 3 epsilon naught. And using the similar formula for the average energy, the expectation value of energy in the earlier problem we have already obtained. It is sum over of n Pn En. That is, here two states are possible with equal probability half. Therefore half epsilon naught plus half 3 epsilon naught. So this is the average value of energy which has been easily calculated by using the formula.